Hi, my name is Mike Claron. I'm an engineer on the Android development team. Android is an open software platform for mobile development. It is intended to be a complete stack that includes everything from the operating system through middleware and up through applications. Now I'm going to talk about how Android can achieve smooth integration of components that are written by different authors as the user navigates forward and backward through the experience. In Android, every application runs in its own process. There's a lot of benefits to this. It gives you security, protected memory. It means that an application that's doing something CPU intensive won't block other critical activities like answering the phone. So all applications are running in their own processes, and the Android system itself is responsible for starting these processes and shutting them down as necessary to reclaim resources. I have an example that shows how that works. Now, to explain this example, let me set up the scenario. In this example, the user is going to navigate from the home screen to their inbox in the mail application. They're going to select a mail message. From the mail message, they're going to follow a link out to some web content in the browser. And then from the browser, they're going to click on something that takes them into the Maps application, which is a not unreasonable scenario. Now, when they do this, they're going to actually navigate through 4 different applications running in 4 different processes that are potentially written by 4 different authors. From the user's point of view, none of that is important. What they want is to be able to navigate forward, clicking on what they want to click on, getting the component they want to have, responding to each click, and then they want to be able to go backwards and get back to where they were. And in particular, they don't want to have to worry about which applications are running, how much memory they've consumed, how much memory is left on the device, whether they can launch that next process because all the resources have been taken up. So the Android system manages all that for them. Here's how it works. At the start, the user is on the home page. There are 2 processes in this example that are running. There's the system process, which contains the activity manager. That contains the common backstack that is used by all activities, regardless of which process they run in. And then the home process is running, and that has the home activity running inside it. Now, before launching the mail application, the system is going to save the state of the home application just in case anything bad happens to it. And you'll see that bad stuff in a few minutes. So the home application has saved its state in a little parcel that has been moved to the system process. And at that point, the system can create the mail process. We can then launch the mail list activity into that process. And now that's what the user is seeing on the screen, their mail list. If they click on a particular mail message, then that creates a request to launch the next activity. That goes to the system process. Again, before a new activity is launched, we save the state of the last activity. So the mail list saves its state into the system process. It's worth noting that the state that it saves is not every message in your inbox. It's meta information about the current state of the activity. Things like where you are scrolled to in the list, which item is selected. You don't have to store the complete mail list in that parcel. So now that the information has been saved, then the system is free to launch the next activity that shows a particular mail message, and now that is what the user sees on the screen. From the mail message, they then click on a link to go out to the web. So again, another request is created. The state of the currently running activity is saved in the system process, and now we need to create a process to run the browser in. So we launch the browser process, we launch the browser activity into that process, and the user is now looking at the browser. We're going to do this one more time, where the user clicks on a link in the browser to launch a map. We create the request. We save the state of the foreground activity, in this case the browser, and we would like to launch the Maps application, but as you can see, we're out of room. So in order to launch the Maps application, we have to find a process that we can kill. We don't want to kill the home application because we use that for a navigation hub. We want that to be always available, so it's always responsive. We don't want to kill the browser because that's the activity that the user just came from. But the mail application is a few frames back on the backstack. No one's looking at it. It's a perfect candidate to kill, and so it's gone. Now that the mail application is gone, we can create the Maps process And in the maps process, we can create the maps activity, and now the user is looking at the map. So it's worth noting that all of this happened without the user being aware of any of the machinery. From the user's point of view, they clicked on mail, they went to mail. They clicked on a message, they went to a message. They clicked from the message to the web, they went to the web. From the web, they clicked on a map, they went to a map. The fact that these are different processes, different applications, different developers, it's invisible to the user, which is as it should be. Now, the reason we saved all those little pieces of state information in the system process is so that we can go backwards and the user can navigate backwards as seamlessly as they navigated forward. So from the current state, if the user hits back, the first thing that we're going to do is pop the Maps application off the top of the activity stack and restore the browser. The browser doesn't actually need to restore its state because it's the same object. So at this point, we can just discard the saved state that was stored in the system process. And now the user is looking at the browser. That's the foreground activity. If they hit back again, they are expecting to go back to the mail message that they came from. Unfortunately, the mail process isn't running anymore. So the first thing we have to do is make space to run the mail application. We do that by killing the maps process and starting the mail process. Once we've done that, we can then launch a fresh copy of the message activity. This is a new copy that doesn't have any of the state that the user saw when they left. In order to get it back into the state that the user is expecting, we then take that saved parcel of information from the system process and we restore the state of the message activity. Once we've done that, it's ready to be shown to the user. We can pop the browser off the top of the activity stack, show them the message activity, and they're back where they started. If we do that one more time, if we hit back again from the mail message to go back to the mail list, we don't have to create a new process because this one is still running in the mail process. We just create a new instance of the mail list activity. That again is a fresh activity. To restore its state, we take the state from the system process, give that back to the mail list. Now the mail list is in the same state that it was when the user left. We can pop the message and the user is back where they came from. So what this example is showing is that the user can navigate forwards and backwards through multiple activities that run in multiple processes that are provided by multiple developers and have a very seamless experience because the Android framework is doing the hard work of launching and shutting down processes to manage resources and making sure that the state is preserved as the user expects. If you're interested in finding out more about Android, I encourage you to visit the developer site and download the SDK. In the SDK, you'll find a lot more documentation and sample code, and you'll also be able to try building applications of your own. There's also a developer group that you can join to find out more information, and I also encourage you to check back frequently because we'll be posting updates to the SDK as the platform matures. Thank you for watching.